All right. Hello, I am Johanna Ratliff, and what you have just walked into, you were hopefully anticipating the stream, the cache, and the store. This is the history and development of Cloud Foundry's logging and observability platform, and it is a deep dive. So we have it listed at 70 minutes. I really hope it's not 70 minutes. And if it is, that'll be fun for all of us. So hello, my name is, as I said, Johanna Ratliff. I'm an engineer at Pivotal. That's my Twitter handle if you're on Twitter and you want to know more about Loggregator. All right, so why are we here? This is a talk about kind of 3 years of history of the observability platform itself. I have been working on Loggregator, Log Cache, and Metric Store for the last 3 years. So some of the whys behind how things ended up the way that they are, and how we made some of the requests that consumers wanted out of this observability platform happen for them, the decisions we made along the way. And really, to sum it up, how we ended up with the logging and metrics platform, everything for observability and visibility that you have at your disposal today. I'm going to dive through that. So before we start, a few operational definitions. So logs versus metrics. You'll hear me speak about some of our products, Metric Store, Log Cache, Loggregator. There are some terms in there that can often be overloaded. So logs versus metrics, for the purposes of this talk and for the purposes of the observability platform in general, are logs can be thought of as a set of everything that is flowing through the Loggregator pipe, just everything that you are transmitting that has data, probably some subset of logs, right? And metrics can be thought of as a smaller subset of that. Anything that you could classify as a counter or a gauge, something that has a value and a listing, and you could probably do some kind of calculations on those. Those are your standard metrics. But think of it all as logs collectively. Observability platform. I've already said that like 3 or 4 times this talk. So the observability platform, from the perspective of this talk, is really everything that we've built to enable visibility of your platform. Not only the components that are there, but also what's being run on them, your apps, your services, everything that encompasses visibility about a Cloud Foundry or what is running on it or anything that touches it, right? That is observability platform, anything that enables you visibility. V2 for Loggregator. You'll hear me say V2 in the Loggregator context a lot. And just as a fair warning, that means 3 different things. So let's unpack that really quick. Loggregator V2, the first V2 for Loggregator was really the conversion from UDP to a transport protocol of gRPC to enable reliability, and we'll talk about that a little bit later. So when you hear V2 from UDP to gRPC, that's a reliability V2 upgrade. We were also in the middle of a couple different rewrites simultaneously. So you're like, why isn't this a V3 and a V4? They all happen consecutively, but they're different. So, so your secondary one that you're going to want to know about is the envelope structure. The things flowing through Loggregator changed during our V2 rewrite. So the first one, you might be familiar with those value metric envelopes or an HTTP start-stop metric envelope. Those were all flowing through Loggregator in our V1 process. Our V2 process, we took it to a little bit more of a traditional structure of timers, events, logs, gauges, counters, things that you would see in Google's Site Reliability Engineering book, things that we can, as colleagues, speak about on the same terms together instead of being like, we made up a thing called a value metric. That's amazing. I don't know what that is. So your third V2 for Loggregator that you're going to run into is the reverse log proxy. So many of you have consumed from the Firehose stream Many of you may be familiar with the traffic controller. So in the Loggregator architecture, your traffic controller was your original reverse proxy from a bunch of routers that were sharding your logs and things downstream to give you a collective streaming endpoint, right? Traffic controller was the V1. We did a rewrite to upgrade your traffic controller to something called an RLP. We named it a reverse log proxy. That is what it does. We stopped with the I think it was weather-based metaphors for all of our components and just named them what they are. So your V2 for Loggregator, we're going to run into all of these different terms, so wanted to set the stage for that a little bit. Okay, so diving right into Loggregator. So when you think of a Loggregator, you might be imagining a stream of metrics that feels something like this. It's all coming from your Diego cells, from your apps, and it's trickling down to you, and you're able to consume them. Unfortunately, the Loggregator experience is a little bit more like this. It is a lot of data coming out, and you can leverage it in a very productive and very unique way, but it does take a lot of control, and it is a little bit exciting. And unfortunately, the Loggregator experience used to be something closer to this. So if you've consumed from Traffic Controller, you can relate to this GIF strongly. It used to be this experience of like, here is all of your data. You are going to be responsible for controlling it. And so a lot of the time, the data is controlling you instead of your ability to leverage that and really create some visibility for your platform. So when you've got the stream of data dragging you around instead of really enabling you to see things about your platform, that's what we wanted to improve from the Loggregator experience, right? So what is it? So Loggregator is a back pressure resistant logging pipe through which your platform and app logs and metrics flow. So every single component of Cloud Foundry, every VM that is running Cloud Foundry has a Loggregator agent on it through which all of these metrics and logs are getting into this. You can think of it as one large pipe. And then your downstream endpoint through which many components and users consume all of this data, we affectionately refer to as a fire hose because that is the amount of data coming out of it. So let's unpack back pressure resistant for a little bit because that informed so many of the decisions that we made as we were building Loggregator. So back pressure resistant, our goal when building Loggregator every step of the way was to make sure that no user downstream and no component downstream, no piece of Loggregator even, could be causing reliability loss farther upstream. So whenever I'm talking about back pressure, that's really what was happening is we wanted to focus on your traffic controller not causing any conflict in your logging router. Your logging router couldn't be making anything from a Loggregator agent drop data. Once it was on its way down that pipe, there was no way for it to get clogged up. It might get lost, but it couldn't cause conflict farther upstream. So the way that it was, I think we saw from that GIF before, it really had, it really had this reliability impact that we used to speak about Loggregator's reliability without really measuring it. So we had some reliability problems. We had some lossiness that was very common in a Loggregator infrastructure. And we also had kind of unordered chaos, right? It is a fire hose of data that a lot of you downstream were responsible for keeping your own apps up to be like, oh, good, I am going to consume all of this and then filter it the way I need, right? That wasn't as much enablement for you as it was putting the responsibility on you. So what needed fixing? So number one, reliability. And we'll speak a little bit more about this later, but effectively, our reliability prior to all of the V2 upgrades, so I would say 3.5, 4 years ago, our reliability was at about 75%. But we didn't know that until about 3 years ago, because as I previously mentioned with Google Site Reliability, we decided to dive in and say, okay, we know that people are having problems with lossiness. The only way we're going to improve that for them is to be able to see what kind of loss we're experiencing. So really setting those objectives and measuring end to end on our Loggregator throughput, what was getting through at a consistent and reliable rate at scale, at load in production, how that was looking in terms of reliability. And what we thought was 99% was a little closer to 75%. So that UDP to gRPC protocol upgrade is one of the big things that improved that. And we can actually prove it because we have numbers this time. So the other thing that we got asked for a lot was ordering and filtering. If you know about the architecture of Loggregator, what happens is every single agent is outputting data, and then you've got downstream routers that collect and then are sharded across it, and then you've got a reverse proxy downstream that really brings it all back together. But reverse proxying things that are coming through in a stream, unless you are willing to sacrifice some reliability in that reverse proxy and sacrifice your promise to back pressure in that reverse proxy, you are going to experience some higher load, some higher computational load in order, and some higher memory load in order to just get these things in order. And that was one of the biggest asks we always had. They were like, can I just have things in order? You have timestamps. It's not that hard. So I'll talk about some of the easy approaches in just a second. Okay, noisy neighbor. Can I get a show of hands who has heard this terminology before? Yeah. So for noisy neighbor, what we're experiencing is effectively the risk of having any neighbor on your platform as, let's take an application, for example. Let's say I'm application A, and I'm sitting over here, and I log a few things every 30 seconds. I've got some metrics going out about myself. And there is application B scaled to 10 instances, and it is crashing, and it's in debug mode. And it is outputting a large amount of data. So all of that data coming through this one collective pipe, effectively the risk is, depending on how your Loggregator components have been scaled, you're risking a throughput that becomes dominated by this one noisy neighbor's logs and metrics. And it's saying, I have decided that most of these components are going to be responsible for transmitting my stack trace, and app B, or app A, me, is at risk for having, okay, so a single log got dropped. Well, I don't log that frequently, so it's a large percentage of the logs that I cared about, as opposed to being in a fight for who can be the noisiest and scale up your Loggregator the most to handle everyone competing for the most load on this system. So your noisy neighbors situation is really the risk of any one app, service, component, anyone, having their logs and metrics kind of hijacked by system underperformance, under load from somebody else, if that makes sense. And look back. That was the other main thing that we wanted fixed from a Loggregator perspective for consumers. They said, hey, you're throwing all of this data at me, and if I miss it, there is no fix for it. It's gone into the ether. So solving some way that I can look back just 5 minutes. Okay, So we actually ended up with 2 solutions for this collection of needs because we looked at Loggregator and we're like, this might not all be solved in Loggregator. So what we're going to walk through is a little bit of log cache was the solution for half of these needs, and then our reverse log proxy and our V2 upgrades for Loggregator were our solution for half of these needs. So let's look at that. The reliability was improved actually in Loggregator itself. Now, we kept reliability consistent when we built log cache, and I'll speak about that in a moment, but the reliability was actually fixed in Loggregator. So by upgrading that UDP protocol, which has no guarantees, to a gRPC protocol, you've got a big improvement right there already. And then also from the rewrite of our traffic controller to a reverse log proxy, that V2 reverse proxy really had a stronger focus around reliability too. So what we got, we'll get to that in a second. So what we got for reverse log proxy was a gRPC gateway that component authors could use, and they were getting better reliability. But downstream, a lot of users were still having to consume from the fire hose. So what has been built recently, keep in mind not all of this is chronological, what has been built recently post-log cache was an RLP gateway to enable that same HTTP API from your RLP instead of your traffic controller. So you can experience all of those V2 upgrades with your HTTP API, whoever was consuming from that stream initially. So I get the upgraded envelope styles to say I would like to be able to speak with my colleagues about counters and gauges and not whatever an HTTP start-stop metric is. We made that up. And I would like to be able to be consuming from this upgraded reverse proxy architecture. And also getting that gRPC was Loggregator wide. So if you are consuming from traffic controller, a lot of those improvements, that's still in your traffic controller HTTP API, because if you hit that stream endpoint, you are getting the benefit of gRPC all the way up and down the Loggregator architecture, okay? So looking at these 4 things, a lot of them, as I mentioned, there's kind of this mindset of you have a reverse proxy and you have some buffering in there. Can we not create a situation in which I can do some ordering, do some filtering within that reverse proxy and let people consume it from the RLP itself? By the way, RLP does have filtering now because of the selectors that we created in it. It's what enables log cache. So there is half of the fix for filtering in RLP, half of the fix for computation in this very hefty box that I've allocated for a reverse proxy, right? And so one of the things that you often run into is the idea of late messages. So if I'm over on this Diego cell and I'm outputting data, right? What happens if my reverse proxy is like, oh good, I've taken this envelope and this envelope and this envelope and we've ordered them and we're gonna send them out to you, and maybe we use batching. Hello, this is great, have some ordered data. And then right as it's sending it out, it gets a 2-second-old log. It's like, I didn't know about that when I was ordering. This adjustment for we don't really know if something slightly older is going to come down the pipe at any given time is what really inspired us to build a short-term cache. So the physics behind being sure that things have come all the way down the pipe and aren't just lost, because when things travel across wires, there's not 100% reliability, right? That's fundamentally impossible because physics. And so when you want to be sure that you've gotten most of your things in order and most of your things filtered, you end up having a lot of conversations about cap theorem. Okay, let's decide on if we're doing eventual consistency. We need more storage than is available to us in a reverse proxy, because that's not its job. So diving into the cache that we built to solve this. What is it? So log cache is an ephemeral self-pruning storage for everything from the fire hose. And what it really is it's a map of your source ID to a red-black tree of every single log and metric that pertains to that source ID. So that is how we built the cache. It is horizontally scalable. You may have seen it's often deployed as co-located with your Doppler VMs. Also, your Loggregator routers are what those Doppler VMs are. It's co-located because they themselves are just routing metrics and logs around and back and forth. So it's computationally intensive, but it wasn't using a lot of its memory. So we were like, well, we'll take that. We'll take the spare memory. So we built a cache co-located with Doppler, but keep in mind, it's actually consuming downstream from RLP, and then it's its own independent component. It just happens to be co-located on that Loggregator component VM. So a lot of the time there's confusion of like, does it dump into log cache at the exact same time it dumps into Doppler? No. So downstream from RLP. Yeah, it is an ephemeral self-pruning cache. And you get some really good experiences too, because in Loggregator, you have that CF logs from your CF CLI, and you also have the HTTP API that you can consume from. But with log cache, we went ahead and wrote a CLI plugin to really better enable the usage of some of those filters, et cetera. So instead of kind of writing our own query language or anything like that, we were like, what if we just write a CLI plugin so you can say, you know, tag, envelope type, I would like all of my counters from this source ID, please. And that is, if you've ever used CFTail or CFTail follow, we made it a very traditional Unix experience. Okay, so talking about the use case for log cache, we talked about people wanting look back for debugging, honestly, and figuring what's going on with your apps. Because like I said, a lot of people, I've seen a lot of folks with these apps that are, okay, we're gonna dump a bunch of logs in order to see about the reliability on Loggregator. Let's see downstream how much of these we actually ended up with. And there are these on-the-fly tests instead of being able to look back about metrics about how your Loggregator is doing, how your apps are doing. And so when the previous PM of Loggregator did a lot of this research, he was finding out that so many people, their main request was, look, I just want to be able to look back 5 minutes and know what was going on then so that I can look at patterns for myself. And so the cache is really built for that. It's built for filtering, and it's built for ordering, because like we said, being able to dump everything into the same place before you order it and have a little bit of a delay so that you can be assured of eventual in the reverse proxy is very important. And it was built for people who needed that 5 to 15 minute window of what just happened so that I don't have to try and push information through again to replicate it. And mostly enough state that downstream folks didn't have to store it themselves. So I don't know if any of you have ever been on a team that is doing observability work and consumes from the fire hose, but a lot of our colleagues would want to see metrics and logs about this thing, and they would end up rolling their own solution to this cache every single time. Like here's a DB that we've just put in the middle. We don't actually need a DB, but we need some form of slightly older than right now data to be stored. And so a lot of our colleagues, we were noticing, ended up rolling their own very similar solutions time and time again. And so when that is not the main purpose of your product, when focusing on the reliability of this cache is not the main purpose of your product, it becomes a side focus and it doesn't get as much attention. So those downstream products of saying, here, I would love to graph this, I would love to show you metrics or old logs about this, get less reliable data from the fire hose because everybody is independently rolling their own. So really what this fixed was creating the cache fixed a lot of the observability teams need to roll their own. And it also fixed a lot of folks who are like, hey, I end up needing to consume from this fire hose and dump things back in order to see what just happened because I need to replicate it time and time again to see what's happening. So the log cache experience of saying, I would like to tail this source ID. I would like to tail and follow this source ID. I would like to look back to a start time 5 minutes ago and an end time 3 minutes ago because I just want to know what happened. And having that still available after your one query for it is very important for folks. So what else did people want? Oh no. So what else did people want? Really, we noticed that even as folks were rolling their own cache, like intermediate cache, I mentioned that the cache itself is horizontally scalable, and we saw folks trying to really push it to its limits, which is awesome, and say, oh, okay, so if I have a high memory VM, and I scale this out to 40 instances, because it's already co-located on my Dopplers, and I need 40 Dopplers for the amount of logs that are going through here. Then you end up seeing that a lot of folks want persistence. If you want any kind of charting, any kind of queryability on metrics a week ago, because this is a cache meant to be 15 minutes long, 2 weeks ago, 6 weeks ago, that kind of charting requires actual persistence. And like I said, this is an ephemeral self-pruning thing. Oh, one thing I also forgot to mention on what did this fix, we previously spoke about the noisy neighbor problem. So when you'll remember I explained the architecture of log cache where you have a map of source IDs to red-black trees for each source ID. Because of the way that we store that information, your noisy neighbor problem, once it's come through Loggregator, is eliminated because I have my own tree for my own logs, and I can say, hey, my cache duration for my source ID, because I don't log that often, maybe I have 100,000 nodes on this tree, my cache duration for my source ID is actually a couple of days, but noisy crashing app, their cache duration is 15 seconds, but they did that to themselves and they didn't do it to me. So that was a pretty important fix I just kind of like glossed over initially, maybe. So we talked about the persistence being really important to people. So we created metric store. And we initially started with those definitions about metrics v logs. So keep in mind, this is a storage engine only for metrics at this stage. So metric store is similar to log cache, and by similar I mean forked from the architecture of log cache, except instead of that map of trees, it's actually backed by a real-time series database. We're using the influx engine. And then we've got the log cache architecture, which kind of plugs this entire thing into your Cloud Foundry authentication and routing experience already. So what that looks like for us is that I, as a user, instead of saying, listen, you want app metrics and you want queryability, you're going to have to basically find someone who's admin and write that plugin for yourself. What this enables is because we've hooked up this same architecture as log cache to a time series DB. Pardon me. what this looks like is that I can, as an app developer, come in and say, hey, I would really love this query about these two apps. And our metric store and its auth proxy will look at those, check with UAA, check with CAPI, confirm that you do actually have access to those things, and then respond with your queried data. So what this means for operators is that you don't have as much responsibility for those authentication switches and for saying, hey, who is allowed to see this? Who should I be opening up this stream to? Because metric store itself can be leveraged just based off of their UAA credentials. So that eases up a lot of responsibility in the operator sphere. So like we talked about, people really wanted persistence and they wanted queryability. So Logcache was our first pass at using Prometheus query language. There are a couple endpoints on Logcache that do enable that, and we learned from that because it was painful. When you try and use a mature query language like PromQL against a cache that is indeterminately long, you get a lot of risk in terms of what might be coming out and what might look like correct data and is inherently misleading. So when you're using a mature query language like PromQL, you really do need that extensive persistence, and you don't need things self-pruning themselves out of your data collection in the background, right? So with metric store, people really wanted to be able to say, hey, I would love information about this source ID. I would love information about this component piece, and get those consistent answers. So metric store, by default, stores 42 days, and it inherited that self-pruning from Logcache. So we still apply that to metric store, but it's adjustable. You can say, hey, I'd like 100 days if your org allows for that kind of storage. But what it does do is say, for the look back of these 6 weeks, you are guaranteed that persistence. And this really fixed people's situation where they were like, hey, I would love a graph. I would love a chart that I could roll for myself about any source ID, focusing on any query that I might want to craft. So if you look at something like Grafana, right, they have that inherent support for PromQL. And if you've crafted your own query about things that are important to you on your particular platform, it's enabled you to create those charts for yourself instead of being dependent on what other people might think your platform looks like. So yeah, the Prometheus API and the Prometheus query language are both what metric store was written around. So instead of crafting our own query language, instead of giving you specific selectors or filters, what we've done is given you a healthy time series DB in your platform that is already linked up with UAA and with CAPI, but has this very mature and very well documented tool behind it, which is PromQL and the Prometheus API. So we've talked about use cases already a bit, but yeah, really charting your trend data and being able to pay attention to all of those service level indicators and service level objectives, not having them defined for you, but empowering you as an operator on your platform to say, hey, I would like to be measuring these specific things, and these are my goals for it, and being able to see those charts for yourself instead of having to work around the platform, having the platform work for you to give you that visibility. Okay. So in summary, we've created a observability platform as a whole that hopefully leverages each of these, or hopefully enables each of these use cases for you to leverage the kind of data that you need for your situation, and realizing that that's not one size fits all, and that a streaming endpoint does need to be the first step in getting all of that data to you, but then enabling that filtering and enabling that visibility for each of your use cases, and not forcing you to roll your own solution, which often all of our solutions look very, very similar, downstream from the Loggregator fire hose. And yeah, I think basically enabling that experience for all of these folks who can say, hey, I am able to focus on this particular piece. I really cared about charting and data, and when you gave me a cache, it was just not in my set of requirements. Like, look back on component metrics was not important to me, and now I can go over here and choose this peer of the cache that really does enable me for what I need. By the way, metrics store is deployable now. It's in the experimental directory of CFD if you are looking for where that exists. And yeah, I think the last thing is just really a call for improvement. Like, we built all of these things based off of consumer feedback and really strong activity in the open source channels of saying, hey, I've been building this and it hurts me. Hey, I've been building this similar thing and I did it this way. And look, what I really need from you is something completely different. And so continuing that open source community feedback, we really are working on improving. Right now, there's a big focus on improving the Loggregator agent itself to become a more powerful tool for all kinds of different metrics, structured logs, everything that you might be wanting to put in, instead of pigeonholing you into our direction. And so just continue giving us that feedback and engaging with us in the open source Slack channels, et cetera, and on GitHub, because that is how we're going to continue to build out this observability platform and really enable visibility for all of you about whatever you'd like to see, hopefully. So thank you. Any questions? Yes, hold on.
So you mentioned Grafana, and you mentioned that these are Prometheus API compatible.
Mm-hmm.
Has your team or any of the folks that have been using it that you know of been able to directly consume the RLP gateway as a Prometheus or as a data store in Grafana, so that it's talking straight to it rather than having a third party like Prometheus to collect the data and keep it?
I don't think I have any off the top of my head, because we've been focusing a lot on leveraging it from Metric Store. So RLP Gateway itself is, again, that HTTP API, but it is not the Prometheus API. So I don't have any examples of that for right now, but I can follow up. Any other questions? Yeah.
I'm wondering if there's any plan to move the CF tail stuff into the core of the CF CLI, so it becomes like this is like now the default way to get logs instead of like a separate plugin like you have now?
Yeah. So right now the CF logs experience is still your standard, and ours still is an adjacent plugin. I actually don't know where we landed on that. There were talks. The CLI is going through a pretty massive rewrite right now, and so I don't know where we landed. I know it's been discussed. Any other questions? Yeah. Thank you.
You said log cache introduced persistence, and if I understand it correctly, it's not deterministic how long you cache log information. I think it's based on a certain number. How does this comply with GDPR?
Yeah, so log cache itself actually didn't, it's ephemeral. So what you do experience with this cache is that anytime you're rolling your boxes, they actually end up dropping that entire history. And so with GDPR, I don't know, I think that might be operator specific because we just built this ephemeral cache that is like, hey, you could drop the data in me if you needed to. But in terms of implementation of saying, oh, hey, a year ago, look back, I would be hesitant to make any like sweeping generalizations about like, oh, and then it's a year ago, so people are able to request like, please get rid of that. Because my only solution for that would be to roll the boxes and be like, now start building your cache again. But realistically, a lot of the log cache content, and you're correct, it is like a set number of nodes that can be scaled based off of operator preference. I think it defaults to like 100,000. So for some folks, that does look like 5 minutes of cache. For some folks, that looks like 3 to 4 days of cache. I don't really know how implementation against a please drop this old data would look like, predominantly because it is pretty short term.
So there's no option to limit it to a certain period of time?
There is actually. So if you go into the Loggregator configuration, or sorry, the log cache configuration, you can say, this is my number of nodes, but also start pruning things that are older than this. And you can say, hey, I don't want things, I might be mixing up my metric store and log cache configurations. You can definitely prune based off of memory percentage. And then the time thing, I might have to look back into, because I don't think that's configurable right now. That might be configurable in metric store and not log cache right now, but we could add it.
This would be nice, because then you could be compliant if you say we limit the storage of logs to maybe 1 day, and whatever comes first, 1 day or 100,000 entries, it gets pruned automatically.
Yeah, that's definitely a thing we could add pretty easily. Yeah.
Thank you.
Any other questions? Yes?
Does the metric store store everything from the Loggregator, so all logs and metrics, or is it only a subset?
Metric store is only metrics. Yeah, just because of the way that the cardinality works out on any given platform, if you are trying to store those logs that can look way, way different, like between apps and components, the query speed was deeply sacrificed when you were trying to optimize for both like the cardinality of the metrics and the logs. So there are two different responsibilities right now. But a lot of the benefit that you get out of the PromQL experience is like metrics focused anyway. So.
Is there an idea to have something similar for logs, to have something platform integrated for log storing, so you don't have to store it outside for like a history?
There is a thing in the works that I don't know if it's going to be open source or not. So maybe. Any other questions? All right. Thank you all so much for coming.